Let's go through LeetCode 2031. Count subarrays with more ones than zeros, and give a binary array nums, and it contains 0 and 1, and return the numbers of subarray which has more ones than zeros. We'll see it has n is 10 to the power 5, so we know the time complexity we should do. We cannot do more, the should be O(n) or O(n) log n time complexity for this question, right? So if we do this question, brute force, the worst case is that we brute force any subarrays. So there is for I and J, right? For any I and J, and count those kind of ones between I and J, right? And so there are two for loops. This will be n squared. If we count, right, that is another O(n). So that will be O(n) power 3 time complexity. One of the things we consider is that we optimize this count, those kind of ones from I to J use prefix sum, right? So, but doing like this, we still need two for loops that will be O(n) squared time complexity. But this gives us some kind of hint that we need some kind of prefix sum, right? So let's consider those kind of features for this kind of question. Because this question it only contains 0 and 1, right? So what we're thinking about is that there is a trick is that we replace those kind of 0 to be -1. So this will be a very common trick. So that is if we are trying to iterate those kind of I, right? For example, every time we look at this prefix sum I, we try to find that is um, um, we can find previous to index I, how many prefix is smaller than prefix I, right? And count the result. But this will be also be O(n) square time complexity. So the tricky part for this one is that we have such a concept is that because we will see this prefix sum will be some kind of consecutive, right? Because if we have nums, if it is 0, it is a prefix sign will add 1, right? If it is 1, we add 1. If it is 0, we minus 1. So it will be always be consecutive. So so there is one of the very important feature here. We can observe that is the tricky part which can optimize this question. Is this prefix sum? If it appears the first time, and also this nums I is 1, right? That means all of the number before all of the j before I have prefix of sum j should smaller than prefix sum I. So this is one of the most important feature because this is consecutive. Otherwise, if, for example, if we can use a contradictor to prove it, right? So that means the last one it is an increase. If we have a previous one which equals, right, which is greater than current one, right? So it must passing this kind of line, right? Pa- must have a cross between this line. That means it must have a prefix sum equals current prefix sum I. So it is impossible in the previous index there is a prefix sum j um, greater than prefix sum I, right? Because that is consecutive. So this is the most important feature. So that is if nums I equals 1 and this prefix sum this first time appears, then it means all of the prefix sum j should be smaller than prefix sum I, right? So prefix sum j, for example, it can be something like anyway like this, right? But it will never be higher than prefix sum I. Otherwise, it must cross this line. The prefix sum I must appear in a previous index. So this will be the most tricky part for this question, right? So what we do is that we use a prefix sum map, and if this one um, this prefix sum first time appears, right, and also current num I equals 1, that means all of the previous prefix sum is smaller than prefix sum I, right? Of course, here, if this first time appears, if this num equals 0, right? Because that means this is decreasing. That means all of the prefix sum j should be greater than prefix sum I, right? But uh, but the thing that we are trying to see if this is smaller. If this is smaller, what happened? That means um, that means for all of the subarrays, and we have pj smaller than pi. We add one more index, right? We add one more index. Um, and we can have an dp, uh, for example, dpi means how many subarrays end with index I, which has more ones than zeros, right? So if so in this case, if the first time prefix sum appears and also this num is greater, that means all of the previous prefix sum j is smaller than prefix sum I. That means all from the index um, 0 to I, right? We can have a subarray and with I minus 1 to I, right? And also I minus 2 until 0 to I, right? So all of this will contribute to our result. So that means um, that means uh, our DPI, right, should should from 0 to I should have I plus 1, right, to our result. So this will be the first part. And the second part is that so that means that if this is prefix sum appears the first time and also this num is negative, right? So we will contribute I plus 1 to our result. And if it is we already convert these nums to be -1. If it is -1, right, of course, we don't need to do anything because anything end with this kind of I will be 0 greater than 1, right? So if so this is the first time it appears. And what happens if it is not the first time it appears, right? Uh, if it is not the first time it appears, for our prefix sum, we use a map. And the key will be the prefix sum. And the value will be the last index. This prefix sum appears, right? So how can we check whether this prefix sum it is the first time it appears? Is we check if this map contains this prefix sum or not. So if it contains, right? If it contains this kind of prefix sum, then that means we can get a previous index, right? Previous index and I. That means, for example, this is J, right? So that means from J plus 1 to I, all of the prefix sum from J plus 1 to I should be smaller than prefix sum I. That means because after J, this prefix sum is not appear again, right? And this is increasing. Also, we have this kind of line. So what we can do is that we are um, first for previous, if we have dpj, should we have dpi should add equal to our dpj because the later part, the sum is equals to 0, right? So how many subarrays greater we will first have dpj contribute to dpi. And also, we should add those kind of um, subarrays which end with I, and it can extend to j plus 1, right? Because any prefix sum j from j plus 1 to I is smaller than prefix sum I. So, um, so doing like this, we can use the O n time complexity to solve this problem. So let's write code for this. Um, we need to mod and for this question, we need a prefix sum map to store the last index where the prefix sum appears. So we can have a map. For this prefix sum, we'll see in the nums. It will be because the nums we can it can be 1 or 0, right? But after converting, is our nums can be only 1 or -1, right? So for this range, the prefix sum will never be integer array, right? Integer range, so we can use the integer. integer, right? We call prefix sum map equals new hash map. So this is um key will prefix sum, right? Key will be the prefix sum, and the value will be the last index. This prefix sum appears, right? And for prefix sum, actually, we want to add normally we want to add an and 0, 0 to the beginning, right? Sometimes some people want to like to put 0 minus 1 into it so that the prefix sum map uh, index is always is the same as nonce prefix. But the thing that I like to put this kind of dummy to be 0, 0 to it so that to be consistent as a prefix sum array, well, we have one more index, right? So I also put this one as 0, 0, so that when we calculate, we just make sure that prefix sum index is one more index in the nonce index. So we're going to have int n equals nonce dot length, right? And we need a sum and it equals 0, right? This sum we are used to add 1 or minus 1. This will be put to the prefix sum map key, right? And also we check prefix sum map if it contains this sum or not. And it says that we need to model, right? So for the result, it is possible theoretically 10 to the power 5. So we can, to be safe, right? We can have a long result equals to 0. And we need a long DP, right? Equals new long. And here, actually, I suggest for this DP, we have one more index as well, right? So otherwise, because we have one more index, we can have DP 0 to be 0, right? Otherwise, if this is long n, right, the DP initial state will be like a nonce 0 equals 1, then it is one other. But we have one more index. So make sure doing like this index is corresponding to the prefix sum index. And the prefix sum and nonce, they have one more index in the non initial index. So what we do is that for we are iterating index this kind of nonce, right? So what do we do is for int I equals 1, I smaller than n plus 1, I plus plus. Then we'll have sum should plus equal to nonce. Well, let's say this index should decrease by 1, right? If this one equals 1, then that is 1, right? Otherwise, we change this to minus 1. We'll not use 0 to it. So we'll say if prefix sum map doesn't contain t, right? Sum. So if it doesn't contain key sum, we need to. So that means this kind of prefix sum is the first time it appears. It never appears in the previous part. So the previous prefix sum j can either be always greater than prefix sum I, or either to be smaller, always smaller than prefix sum I, depending on what the nonce this number it is, right? So I say if this kind of nonce I equals 1, because that means that means this is should index minus one from um from the nums I minus two to nums I minus one. It is increasing, right? And so that means this is increasing, and the previous one can can only be all smaller, right? Because this doesn't appear because this must be consecutive. So if it is if there is one is greater than current one, then the map must contain this key, right? And also if this one equals zero, means the previous one will always be greater than current one, right? It can never be smaller. So if this one equals, that means um, that means all of the prefix sum j, right? J, which is from 0 to to I minus 1, right? Those kind of prefix sum j should be strictly smaller than prefix sum I, right? So we are asking how many subarrays end with this nums I, right? DPI will be how many subarrays end with this nums I has the one greater equal to zero, right? That means all of the subarrays end with nums I minus one should be able to uh should have one greater than zero, right? So we'll just have dpi equals I. So this is the most important part because we'll see that means 0 to I minus 1, right? And 1 to I minus 1 until I minus 1 to I minus 1. They are all have 1 greater than 0, right? So totally, how many we need to contribute, right? That will be I minus 1 minus 0 plus 1, right? So dpi will equals I. And if this, so here, this is the condition, right? And if this one equals 0, means there is no subarrays end with this number has one greater than 0. That is all of that has 0 greater than 1, right? Because that means this is decreasing prefix sum. All of the prefix sum j is greater than prefix sum I. Okay, so this is the first part. So if the prefix sum map contains this kind of nouns, right? Then what happened? So we need to find the previous index. So let's have int j equals prefix sum map it sum, right? So this is the previous index, right? So that means we have a prefix sum I minus prefix sum j equals 0, right? So that also means the nums j to I minus 1, right? Those kind of subarray, this sum is 0, right? So this part, so that means we can have a dp I. First, it can transport from DPJ, right? Just the original which end with with we because have one index, so that is so for that means originally which end with j minus one, right? How many we can transfer to I minus one, right? Numbers end with. So here the things that we'll see if nums I equals one, right? So what does this one mean? Because uh, j is the last time this prefix sum appears. So that means from j plus 1 or we'll see in the original index that is from j, right, to I minus 1. Those kind of so we'll see let's still consider prefix sum. That means prefix sum j plus 1 to I, right? Those kind of range, for example, prefix sum k will always smaller than prefix sum I, right? So because we can consider from here, that is this range that is prefix sum appears first time, right? So it will never appears anymore because it's consecutive and this is increasing. So that means from j plus 1 to I, it should smaller than prefix sum I. So that means all of the all of the um all of the uh subarray end with I from j plus 1, right? Or say end with I minus 1, that will be from j, right, to I minus 1. Well, will have one greater than zero, right? So besides the transport part, we should also consider for this kind of session how many subarrays which has more one than zero, which added to our result. So we'll have dpi should plus equal to, right? Plus equal to so that means that we want to count how many that is from um this is j plus 1, right? Um j plus 1. So we need to count how many from j plus 1 to I minus 1, right? So should plus equal to I minus 1 minus j plus 1 and plus 1, right? So that is should be like this, right? We need to mod, right? So that is let's say dpi will be equals dpi plus I minus j minus 1 right? So this will be the thing. So the concept is that if it appears in the previous part, that means from this j plus 1, right, it never appears again. And this prefix sum, because they are consecutive, and from j plus 1 to I, the prefix sum will always be smaller than prefix sum I. So our result, right? So that we need to do two things. One is that we should have result result should equals result plus dpi and mod. And don't forget to place the index prefix sum map put sum and this index to this map, right? And in the end, just return int result. This will be -1, right? And let's also write the Python code for this. Uh, mod equals 1. So we can have prefix sum map equals this one and this, right? And we have n equals let's have n we cannot use sum, we can use total result and length, this will be length nums and total to be 0 and result to be 0, right? We need a dp equals this one multiplied by n plus 1, right? So what we do is for I in range from 1 to n plus 1, we're going to have total with plus equal to 1 if nums I minus 1 equals 1, else that is minus 1, right? If total not in prefix sum map, then that is the first time it appears. And it has two cases. If nums, the last number is 1, right? Then all of the previous prefix sum j is smaller than 1, then prefix I. So we'll say if nums I minus 1 equals 1, right? We'll have just a dp I equals I. And we don't need to care about 0, right? Because none of the, if it is 0, none of the subarray end with this number will have 1 greater than 0. So if it appears in the previous sum map else, we'll have get previous index because prefix sum map total. Then we'll have dp. We should have um, the dpi transport from dpj, right? Because from j plus 1 to I, we can treat it as because it's just sum equals 0, right? So how many subarrays end with j should firstly contribute to bi, right? Or whatever. This is j minus 1 to I minus 1, right? Then we are going to have so the things that we also need to see if this kind of nums I minus 1, right, equals 1, right? We don't need to care about I minus 1 equals 0 because that means if this one equals 0, means all of the previous from this kind of um, j plus 1 to I is greater, right? So that means this part always have the 0 greater than 1. So we just need to care about this one is 1, the same as this, right? So if this one equals 1, we'll have dpi equals dpi plus I minus j minus 1, and we should self dot mod, right? And then we need to set the prefix some map this kind of total the last index to it, right? And also we have result. It equals result plus dpi and self dot mount. And in the end, just return result. Result. It will be ON time complexity and ON space complexity because we have a map and a DP, right? So this is one of the best solution I like. And the other method, if we don't like using the trick that the first time it appears, this is smaller, right? We don't have this kind of feature. We count how many subarrays, how many prefix sums previous to this is smaller. And if we don't use this kind of feature, it will always at least be n log n time complexity. Use it like, for example, segment tree or tree map or whatever. But to use this kind of feature, we have ON time complexity, ON space complexity.